Okay, our next method is when to use graphing. So you can use graphing all the time. You can always plug something into your calculator. So one of the things that we would say for graphing is you want to use this when you have access to a graphing calculator, because lots of them don't graph very nicely, and so if you were graphing by hand, it would be hard to tell what it was. But when the numbers are ugly, so if they're really large numbers or really small decimals, those kinds of things are when you might want to use graphing. If we have an equation and we graph it, what part are we looking for? The x-intercept. So once you graph it and you have the graph and you change your window so that it looks nice, you want to find the x-intercepts. But remember, on the calculator, there's not a button that says calculate the x-intercepts. It says calculate the zeros. And so you have to do your left bound and your right bound and all of that when you're using the graphing calculator. The graphing calculator does not work for complex solutions, because when we look at this graph, there's only real numbers on the graph. So you're not going to see the complex numbers on the graph. Remember that those are the ones where the types of graphs where they don't cross the x-axis. So we said there was no real solution. So we just use other methods when we need a complex solution. Another one is when we have a word problem and you're trying to determine when the function reaches a certain value. What I mean by that is, say someone has thrown something up in the air and this is the equation for the path it takes, that's the blue one, and I want to know when it reaches a height of 30. I can just plug in y equals 30 for a second equation, and for that one I'm looking for where those two lines intersect. So on the calculator, I'm looking for the point of intersection instead of the zeros. So those are the two situations. Word problems are really good for graphing if you have your graphing calculator, especially if the numbers aren't great. So the last one is when to use the quadratic formula. So the quadratic formula is good when your equation is in standard form. So your ax squared plus bx plus c, because we know that those are the letters a, b, and c that we need to use for the formula. It's good when a doesn't equal 1. So that would mean we didn't really want to factor it because we didn't want to try to use rooftop. Or if a is 1, but it doesn't factor, then that would also be a good time to use the quadratic formula. Those are our options. So here's an example. We have x squared plus 4x plus 5. It is in standard form, and a is 1. So if a is 1, I would start by trying to factor it. But the only things that multiply to give me 5 are 1 and 5. They do not add to give me 4. If it had been minus 5, it would factor, because I could use a -1 and a +5. But since they have to multiply to give me +5, they either both have to be positive, which adds to +6, or both be negative, which adds to -6. It doesn't factor, so then we would say, okay, we want to use the quadratic formula. Here's another one, 2x squared plus 4x minus 10. Since a is 2, we might not want to factor. Now on this one, if you notice, there is a common factor of 2, so we could divide everything by 2 before we start. But it still doesn't factor, so quadratic formula would be a good option. Also, if you're looking for complex solutions, the only two options you have for complex solutions really are the quadratic formula and the square root method. Factoring and graphing, neither one work for complex solutions, so this is a good one if that's what we're looking for. So that's really, let's go ahead and write what the quadratic formula is in that box, and that's the only other thing we're going to write. X equals -b plus or minus the square root of b squared minus 4ac divided by 2a. And then the last thing I want to talk about is, what about completing the square? So we didn't mention completing the square. Completing the square takes an equation from standard form into vertex form. So to me, it's generally not the best method for solving, but what it is really good for is finding the vertex, because it changes something from standard form into vertex form. Let's see. So completing the square is a technique that's better for finding maximum or minimum since it puts it into vertex form. If you're going to use this, be sure A is 1. We have not practiced completing the square if A isn't 1. It's a little bit more involved of a process. You can do it, but we haven't talked about it. So if you're going to use this method, be sure that A is 1. Okay, so let's look at this one. If we have x squared plus 6x minus 10 equals 0, we're starting with standard form, and we're going to complete the square to find the maximum or the minimum. Now, this one, since A is positive, we know that it opens up, which tells us for this problem we're finding the minimum. So we'd start out by moving the 10 over. That was our first step for completing the square. Move C to the other side. Then we need to take half of B and square it. So half of 6 is 3, and 3 squared is 9. So we add 9 to both sides. When we add 9 to both sides, we're ready to go ahead and factor this side. The left side is a perfect trinomial, so we know that it factors to give us x plus 3 squared. So x plus 3 squared equals 19. If you were going to use this for solving, I'm going to go ahead and show you how to solve it using this first. From here, you would go ahead and take the square root of both sides. So x plus 3 equals plus or minus the square root of 19. And then we would subtract 3. So we get x equals negative 3 plus the square root of 19 and negative 3 minus the square root of 19. So this is, if we want to solve, this is what we would do. If I was going to use this to find the minimum, which is where I think it has its value, then, let's see, from that same spot, the x squared plus 3 equals 19, move the 19 over, and you've got it in vertex form. Because this now looks like a times x minus h squared plus k equals 0. So the plus 3 moves us 3 to the left, the 19 moves us 19 down, and so the vertex is at negative 3, negative 19. So that's pretty nice right there. But those are all of the methods we've used for solving quadratics, and that gives you an idea of when to use each one and how to defend what you chose.